Hello friends, I am with another video today. In today's tutorial, I am going to solve trigonometry problems in which LHS and RHS given, and we have to prove LHS equals to RHS as I have written the two problems on here on the screen. So this type of problems I am going to solve today. So be ready with pen and paper. Let's start to prove LHS equals to RHS in trigonometry. First example, to prove that under root of 1 plus sin x upon 1 minus sin x equals to sec x plus tan x. Step number 1, LHS. Taking LHS, 1 plus sin x upon 1 minus sin x. Now multiplying and dividing by 1 plus sin x. So LHS equals to under root of 1 plus sin x upon 1 minus sin x multiplied by 1 plus sin x upon 1 plus sin x. This is equals to 1 plus sin x whole square upon 1 minus sin x into 1 plus sin x. Now a plus b into a minus b equals to a square minus b square. Therefore LHS equals to under root of 1 plus sin x upon 1 minus sin square x. Now in trigonometry there are two formulae. 1 minus sin square x equals to cos square x, and 1 minus cos square x equals to sin square x. You have to remember this formula, they are very important. 1 minus sin square x equals to cos square x, and 1 minus cos square x equals to sin square x. Therefore here square गलती से रह गया. Okay, now we got here LHS equals to 1 plus sin x whole square upon cos square x, and everything is in the root. So LHS equals to, now taking the root of a square upon b square equals to a upon b. Therefore LHS becomes 1 plus sin x upon cos x. Now splitting into fraction means if a plus b upon c is there, we can write it as a upon c plus b upon c. Therefore LHS can be written as 1 upon cos x and sin x upon cos x. 1 upon cos x nothing but sec x, and sin x upon cos x nothing but tan x. So this is the RHS. Therefore LHS equals to RHS proved. Second example, prove that 1 minus sin x upon 1 plus sin x equals to sec x minus tan x. Taking LHS, now in this case we multiply both numerator and denominator by 1 minus sin x. We get here 1 minus sin x multiplied by 1 minus sin x upon 1 plus sin x multiplied by 1 minus sin x. So here are the 1 minus sin x multiplied 2 times, therefore it is equivalent to 1 minus sin x whole square and here is a plus b into a minus b, that equals to a square minus b square like earlier case. So both are in under root of, that is 1 minus sin x whole square, and 1 minus sin square x nothing but cos square x. Both are in under root of, therefore LHS equals to, the root will go out because they are in the square form, and here is a cos x. Now splitting into fraction, that is equals to 1 upon cos x minus sin x upon cos x. 1 upon cos x nothing but sec x, sin x upon cos x nothing but tan x, that is equals to RHS. Therefore LHS equals to RHS proved. So let's move to the example number 3. And if you have any more problems regarding trigonometry, then communicate on my email and send your doubts, and so I will answer them, I reply them. It is not possible to reply every email, but I see that what are the general questions coming on my email, then I am going to answer them collectively in the form of video. So send your doubts, and also give me the topics you want to watch on my channel, so that I certainly make the videos on those topics for you. Next question, prove that under root of 1 plus cos theta upon 1 minus cos theta equals to cosec theta plus cot theta. So taking LHS, 1 plus cos theta upon 1 minus cos theta. Now to get the cosec and cot, we must get here something like 1 upon sine and cos upon sine. For that, only one option is left, that is multiplying and dividing by 1 plus cos theta. So this becomes 1 plus cos theta multiplied to 1 plus cos theta, and in the denominator 1 minus cos theta multiplied to 1 plus cos theta. Here 1 minus cos theta and 1 plus cos theta, this is a minus b and it is a plus b. This is nothing but a square minus b square, that is nothing but 1 minus cos square theta. Therefore 1 minus cos theta into 1 plus cos theta equals to 1 minus cos square theta, and we know the formula, 1 minus cos square theta equals to sin square theta. Therefore LHS equals to, the same bracket twice, therefore 1 plus cos theta whole square, and here 1 minus cos theta, 1 plus cos theta, 1 minus cos square theta. So that is equals to 1 plus cos theta whole square upon sin square theta. 1 plus cos theta is not the whole square, nothing but if you take out the root, it is 1 plus cos theta, and the root of sin square theta is nothing but sin theta. Here root of a square upon b square equals to a upon b. We follow this idea here. Now we split them into fraction, we separate them. So this becomes 1 upon sin theta, and it becomes cos theta upon sin theta. Here is the formula, a plus b upon c, that is equals to a upon c plus b upon c. Therefore 1 upon sin theta nothing but cosec theta, and cos theta upon sin theta nothing but cot theta. So that is nothing but RHS. That is nothing but RHS. You see that RHS is a cosec theta plus cot theta. So here we got cosec theta, we got here the cosec theta plus cot theta, that is equals to RHS. Therefore, LHS equals to RHS proved. Tan x equals to sec x minus tan x. So we have to prove sec x plus tan x equals to sec x minus tan x. For that, we are using one trigonometric identity. We are going to use the trigonometric identity. What is that? 1 plus tan square x equals to sec square x. Rearranging, we get sec square x minus tan square x equals to 1. We had taken tan square that side. After that, this is a square and it is b square. So a square minus b square equals to a plus b into a minus b. Therefore, this becomes sec x plus tan x multiplied by sec x minus tan x equals to 1. Now, we know the formula. What is the formula? Formula is a into b equals to 1. If a into b equals to 1, then we can write a equals to 1 upon b, or we can write b equals to 1 upon a. Therefore, sec x minus tan x multiplied by sec x plus tan x equals to 1. By using above property, that is a into b equals to 1, a equals to 1 upon b. By using that property, we can write sec x plus tan x equals to 1 upon sec x minus tan x. Or we can write like this also, sec x minus tan x equals to 1 upon sec x plus tan x. In this way, we proved LHS equals to RHS. Here, this is the RHS we proved here. Prove that cosec theta plus 1 upon cosec theta minus 1 equals to 1 upon sec theta minus tan theta, taking LHS. We have to take the bigger side and we can easily prove the smaller side. The bigger side, LHS is a bigger and RHS is a smaller, therefore I have selected here LHS. It is always not advised to take LHS. Sometimes we need to take RHS as well as. Now we have taken the LHS here, that is cosec theta plus 1 upon cosec theta minus 1. Now formula is cosec theta equals to 1 upon sin theta. Therefore, LHS equals to cosec theta can be written as 1 upon sin theta plus 1 upon sin theta minus 1. LHS equals to under root of 1 plus sin theta upon sin theta divided by 1 minus sin theta upon sin theta. This and this cut down. Therefore, LHS equals to 1 plus sin theta upon 1 minus sin theta. Now, as we done in the earlier case, multiplying and dividing. Multiplying and dividing by 1 plus sin theta. So this is equals to 1 plus sine theta whole square upon 1 minus sine square theta. Therefore LHS equals to 1 plus sine theta whole square and 1 minus sine square theta equals to cos square theta. That is equals to that is equals to 1 plus sine theta upon cos theta. Therefore LHS equals to 1 upon cos theta plus sine theta upon cos theta. That can be written as sec theta plus tan theta. And we already have the formula sec theta plus tan theta equals to 1 upon sec theta minus tan theta. Therefore in place of sec theta plus tan theta, we can write sec theta minus tan theta, that is nothing but RHS. We wanted to prove LHS equals to RHS. So what is RHS? 1 upon sec theta minus tan theta, and we proved RHS, that is a 1 upon sec theta minus tan theta. 1 upon sec theta minus tan theta, hence proved. Next question. Prove that sec theta plus tan theta whole square equals to 1 plus sin theta upon 1 minus sin theta. Taking LHS, sec theta plus tan theta whole square. Sec theta can be written as 1 upon cos theta and tan theta can be written as sin theta upon cos theta whole square. This is equals to 1 plus sin theta upon cos theta whole square. This is nothing but 1 plus sin theta whole square upon cos square theta. Now LHS can be written as 1 plus sin theta into 1 plus sin theta, and cos square theta can be written as 1 minus sin square theta. We have the formula 1 minus sin square theta equals to cos square theta and 1 minus cos square theta equals to sin square theta. These are the formulae. So in place of cos square theta, I have written 1 minus sin square theta. LHS equals to 1 plus sin theta, 1 plus sin theta upon 1. Here is I am applying a square minus b square equals to a plus b into a minus b formula. Therefore it becomes 1 minus sin theta into 1 plus sin theta. Therefore LHS equals to, here 1 plus sin theta cut down. What is left? 1 plus sin theta upon 1 minus sin theta. This is nothing but RHS. You see, this is the RHS. Therefore LHS equals to RHS proved. Next example, prove that sin cube theta plus cos cube theta equals to sin theta cos theta multiplied by 1 minus sin theta cos theta. Now we'll take LHS. What is LHS? Sin cube theta plus cos cube theta, and this can be written as sin theta whole cube and cos theta whole cube. Now we have one algebraic formula: a cube plus b cube equals to a plus b a square minus ab plus b square. According to this algebraic formula, we can solve this equation. Come back to LHS. LHS equals to sin theta whole cube plus cos theta whole cube. Here what is A? A nothing but sin theta and B nothing but cos theta. And we have the A cube plus B cube. So in the first bracket, A plus B, that is sin theta plus cos theta, bracket close. In the second bracket, A square, that is sin square theta, minus AB, that is sin theta multiplied by cos theta, plus B square, that is nothing but cos square theta. Properly writing the second bracket. First bracket we already got. Now the second bracket we are arranging sin square theta. Near the sin square theta I am writing cos square theta. This cos square theta I am writing here. After that minus sin theta cos theta. And we know that sin square theta plus cos square theta equals to 1. So here sin square theta cos square theta, there we can write 1. So LHS equals to sin theta plus cos theta. In place of sin square theta plus cos square theta, write 1 minus sin theta cos theta. This is nothing but required RHS. Therefore LHS equals to RHS proved. Before going further for the solving example number 8, I want to clear one thing. If you want to become master of trigonometry, you have to be master of algebra, because the proof of trigonometry, solutions in trigonometric problems, they come from algebra. So algebra is a basic thing. Example, in this question I am totally going to use the algebra to prove LHS equals to RHS. Like here, what to prove? Sin raised to 4 theta minus cos raised to 4 theta equals to 1 minus 2 cos square theta. First of all, I take LHS. LHS equals to sin raised to 4 theta minus cos raised to 4 theta. Then this can be written as sin square theta whole square and cos square theta whole square. You see here, I have done nothing here of trigonometry. I have done algebra here, because a raised to m into n equals to a raised to m whole raised to n. I have utilized this algebraic formula. Then it has become now a square minus b square. It has taken the shape of a square minus b square. And what is a? A nothing but sin square theta and b nothing but cos square theta. Therefore LHS equals to sin square theta whole square minus cos square theta whole square. A square minus b square nothing but a plus b into a minus b. Therefore sin square theta whole square minus cos square theta whole square equals to a plus b, that is sin square theta plus cos square theta, and a minus b, that is sin square theta minus cos square theta. Now sin square theta plus cos square theta equals to 1. So we are having 1 there. And in the answer, what is there in the answer? In the answer, in the RHS, there is no sin term. So to remove the sin term, we have to convert into the cos. So we know the formula, sin square theta equals to 1 minus cos square theta. So in place of sin square theta, I shall be writing now 1 minus cos square theta, and this is already there. So minus cos square theta. Cos square theta has come twice. So 1 into 1 minus 2 cos square theta. That is equals to what? What to prove? We have to prove equals to RHS. RHS nothing but 1 minus 2 cos square theta. So now we are proving here RHS, that is a 1 minus 2 cos square theta. So LHS, when simplified, you got the RHS. Therefore LHS equals to RHS. That is proved. Prove that tan A plus cot A equals to sec A into cosec A. That is what our new problem. Now taking LHS. What is LHS? Tan A plus cot A equals to sec A into cosec A. Now tan A can be written as sin A upon cos A, and cot A can be written as a cos A upon sin A. Then cross multiplication gives sin square A plus cos square A upon cos A into sin A. Now sin square A plus cos square A equals to 1. Therefore LHS equals to 1 upon cos A into sin A. Another formula, 1 upon AB equals to 1 upon A into 1 upon B. Therefore this can be written as 1 upon cos A into 1 upon sin A. And now 1 upon cos A equals to sec A, and 1 upon sin A equals to cosec A. Therefore in place of 1 upon cos A, we can write sec A, and 1 upon sin A we can write cosec A. That is what RHS now. Sec A into cosec A is the RHS. Therefore LHS equals to RHS is proved. Example 10. Prove that sec raised to 4 theta minus sec square theta equals to tan raised to 4 theta plus tan square theta. Now taking LHS. LHS equals to sec raised to 4 theta minus sec square theta. Sec raised to 4 theta can be written as sec square theta whole raised to 2 minus sec square theta, writing in the bracket. And we know that sec square theta equals to 1 plus tan square theta. This identity of trigonometry we are using here. Therefore LHS equals to 1 plus tan square theta whole square minus 1 plus tan square theta. Therefore, now opening the bracket here again algebra I am using. A plus B whole square equals to A square plus 2AB plus B square. Many students, they not do properly trigonometry. they do not become master of trigonometry? The reason is that they are very poor in algebra. Now here, if you don't know a plus b whole square formula, you won't be able to perform this problem. Therefore, make your algebra strong, then only your trigonometry will remain the strong. Otherwise, you can't become the master of trigonometry. Here 1 plus tan square theta whole square, that is a plus b whole square. It become a square plus 2ab plus b square and second bracket as it is. Now 1 plus 2 tan square theta plus tan raised to 4 theta, opening the brackets. See what is the possibility of cutting. Plus 1 minus 1, they cut down. Then tan raised to 4 theta as it is. And 2 tan square theta as it is minus tan square theta. I am writing all the steps to make you understand. I am doing problem to make you understand, not for me. Therefore, I am writing all the steps. Now 2 tan square theta minus tan square theta is nothing but tan square theta. This is nothing but RHS. Therefore, LHS equals to RHS proved. Whenever the trigonometry problems given to us, think what way the algebraic formula are applicable in this problem. Once you click the algebra, then easily you can get LHS RHS of trigonometry problems. Example 11. Prove that sin A minus cos A multiplied by tan A plus cot A equals to sec A minus cosec A. Taking LHS, sin A minus cos A multiplied by tan A plus cot A equals to sin A minus cos A. Tan A can be written as sin A upon cos A and cot A can be written as cos A upon sin A. So sin A minus cos A, cross multiplication, sin square A plus cos square A upon cos A sin A equals to sin A minus cos A. In trigonometry, sometimes problem looks very horrible, very dangerous, but when you start solving it, you will feel that it is nothing. Like this problem is looking very horrible. In left bracket sin cos is there, in the second bracket tan cot is there, and in RHS secant cosec. So all terms are different. As soon as we see the problem, we will feel like quite tough problem, but start solving it, it becomes easy. And so never afraid of problems, start doing it. Do something, you will get the result. Now here sin square A plus cos square A can be written as a 1. So 1 upon cos A sin A. So this is equals to sin A minus cos A upon cos A multiplied by sin A. Now separating, converting each term into fraction. So that is cos A into sin A. You see, A minus B upon C equals to A upon C minus B upon C. That is single fraction converted into multiple fractions. That is what splitting into fractions. Minus cos A upon cos A into sin A. Here sin A cut down, cos A cut down. Then what is left here? 1 upon cos A. And what is left here? 1 upon sin A. So 1 upon cos A nothing but sec A. And 1 upon sin A nothing but cosec A. That is equals to RHS. You see here what to prove? Sec A minus cosec A. What you got here? Sec A minus cosec A. That is RHS. Therefore, LHS equals to RHS proved. Question number 12. Prove that 1 upon 1 minus sin theta plus 1 upon 1 plus sin theta equals to 2 sec square theta. Now we are taking LHS. Quite easy problem. Cross multiplying. Upon then this and this cut down, we get 2 upon 1 minus sin theta and 1 plus sin theta. Here A plus B into A minus B equals to A square minus B square. Therefore, LHS equals to 2 upon 1 minus sin square theta, and 1 minus sin square theta equals to cos square theta. Therefore, LHS equals to 2 upon cos square theta equals to 2 into 1 upon cos square theta. 1 upon cos square theta equals to sec square theta. Therefore, LHS equals to 2 sec square theta. That is nothing but RHS. Therefore, LHS equals to RHS proved. Example number 13. Prove that 1 upon sec theta minus tan theta minus 1 upon cos theta equals to 1 upon cos theta minus 1 upon sec theta plus tan theta. Now first of all I take LHS. In LHS we are having sec theta minus tan theta minus 1 upon cos theta. Now we have the formula. The formula is 1 upon sec theta minus tan theta equals to sec theta plus tan theta. This is the trigonometric identity. I am going to use it. And 1 upon cos theta equals to sec theta. So these two identity I am going to utilize here. So LHS equals to, in place of sec theta minus tan theta, in place of 1 upon sec theta minus tan theta, I can write sec theta plus tan theta, and 1 upon cos theta equals to sec theta. This and this cut down. Therefore, result of LHS equals to tan theta. Similarly, to get the result of RHS, to get the RHS here, RHS equals to 1 upon cos theta minus 1 upon sec theta plus tan theta. Formula is 1 upon sec theta plus tan theta equals to sec theta minus tan theta. Therefore, RHS equals to sec theta minus tan theta, opening the bracket. Sec theta cut down. RHS equals to tan theta. The result of LHS is tan theta. Result of RHS is also tan theta. Therefore, LHS equals to RHS. Proved. Example number 14. In this example, sin A upon 1 minus cos A equals to 1 plus cos A minus sin A upon sin A minus 1 plus cos A. And this can be proved by using the theorem of equal ratios. And for that, step 1. And we know that 1 minus cos square A equals to sin square A. So 1 minus cos square A can be written as 1 minus cos A into 1 plus cos A equals to sin square A. This problem is tricky problem and can be solved by only logic. If you directly try to solve this LHS and RHS, it will become very big. Solution is possible, but the solution will become very big. But by applying this logic, by applying the theorem of equal ratio, it can be solved in very less steps. 1 minus cos A into 1 plus cos A. Sin square can be written as sin A into sin A. Now after that, rearranging. So 1 plus cos A upon sin A equals to sin A upon 1 minus cos A. After that, applying theorem of equal ratios. According to theorem of equal ratio, if A upon B equals to C upon D equals to K, then according to theorem of equal ratio, we can select two integers m and n such that am plus cn upon bm plus dn equals to k. By using this theorem, we can proceed further to prove LHS and RHS. Now, comparing A upon B equal to C upon D. Comparing this problem with A upon B equals to C upon D, where A equals to 1 plus cos A and B equals to sin A, C equals to sin A and D equals to 1 minus cos A. This is A, this is B, this is C, and this is equals to D. Now selecting m equals to 1 and n equals to minus 1, applying theorem of equal ratio, 1 into 1 plus cos A plus minus 1 into sin A. Each ratio is equals to, according to the theorem of equal ratio, then 1 into sin A plus minus 1 into 1 minus cos A, which on simplification gives 1 plus cos A minus sin A upon sin A minus 1 plus cos A. What is RHS? RHS is 1 plus cos A. Here we got 1 plus cos A. RHS minus sin A, we got the minus sin A minus 1 upon plus cos A. Therefore this is nothing but equals to RHS. Therefore 1 plus cos A upon sin A equals to 1 plus cos A minus sin A upon sin A minus 1 plus cos A. Therefore LHS equals to RHS proved. Next example, prove that 1 plus tan A tan B whole square plus tan A minus tan B whole square equals to sec square A into sec square B. Take LHS 1 plus tan A tan B whole square, writing LHS as it is. Now doing square both bracket, following A plus B whole square equals to A square plus 2AB plus B square. I already told you that if you want to become master of trigonometry, be the master of algebra. You see here also we are going to use the algebra. Now opening both the brackets, so here doing A plus B whole square formula. So 1 plus tan square A tan square B plus 2 tan A tan B. Now opening the second bracket, here I am using A minus B whole square formula. A minus B whole square equals to A square minus 2AB plus B square. Therefore tan square A minus tan square B plus tan square B minus 2 tan A tan B. After that, this tan square A I am going to shift to the starting position. So 1 plus tan square A and 2 tan A tan B and minus 2 tan A tan B, they get cancelled, and this tan square A has come here. Then tan square A tan square B, this part is written here. Then plus tan square B. Here 1 plus tan square A as it is, and from here I can take tan square B common. So it is 1 plus tan square A. Now we can take 1 plus tan square A common. So we get here 1 plus tan square B. We know that 1 plus tan square A equals to sec square A, and 1 plus tan square B equals to sec square B. Therefore result of first bracket become sec square A, and result of second bracket become sec square B, that is equals to RHS. Therefore LHS equals to RHS proved. Okay, it's time to say goodbye. That's all for the day. I hope you got through all the problems. Even though if you have any difficulties, Do not hesitate to communicate with me on my email address given in the description box. Meet you again with another video. Till then, wish you good luck. All the best. Bye bye. See you.